Hello everyone! In previous lessons we learned about steel's natural properties, its original performance. Just like uncarved jade, steel usually needs further processing after leaving the factory to meet engineering requirements. Some processes make it extremely strong, others balance hardness with flexibility. Today we will learn how steel transforms through cold treatment and heat treatment. First, let's talk about cold working. Here, cold means at room temperature. At room temperature, steel is stretched or compressed forcefully through cold drawing, cold rolling, and other methods. This is its transformation process. Cold drawing pulls steel bars forcibly through a drawing die with a slightly smaller diameter. During this process, the stress state of the steel is very special. It is subjected to a strong tensile force in the longitudinal direction, and meanwhile, due to the restriction of the die hole diameter, it also bears severe lateral compression. This combination of tension and compression greatly improves the density and strength of steel. Cold rolling turns round steel into deformed steel bars on rolling mills. What changes does cold working bring? The most obvious improvement is higher yield strength. To make it easy to understand, cold working is like physical training for steel. Through force stretching, the internal grains of the steel undergo deformation and displacement, and the internal resistance increases significantly. Just as exercise builds muscle strength, cold working greatly improves load-bearing capacity. However, moderation is essential. Cost of cold working is that the plasticity and toughness of steel will decrease accordingly. The steel becomes stronger, yet more brittle. On construction sites, cold working brings clear economic benefits. Higher strength allows fewer steel bars while meeting load requirements, saving materials. Cold drawing also uncoils, straightens, and even removes rust at the same time, simplifying construction steps. After cold working, steel possesses another remarkable property: aging. Just as steamed buns turn hard after a long time, cold-worked steel gradually gains higher yield strength while losing plasticity. If you cannot wait for the half-month natural aging process, you can heat the steel to 100 to 200 degrees Celsius and keep it at that temperature for 2 hours. This method is called artificial aging. Look at this stress-strain curve. 4 steel bars subjected to cold stretching and aging treatment, their yield point rises from point B to point K. Although the strength becomes higher, please pay attention to the horizontal coordinate. The overall deformation range is significantly narrowed. This means the deformation buffer capacity of the steel decreases, and the material becomes harder, more rigid, and fragile. When talking about cold stretching, we have to mention the once widely reported illegal thin steel bar incident. Some unscrupulous manufacturers overstretch steel bars for profit. A ton of original steel bars with a diameter of 10 millimeters are forcibly stretched down to 9 millimeters in diameter. Although the total length increases, the cross-sectional area shrinks. Most fatally, the steel becomes extremely brittle. During an earthquake, what we rely on most is the ductile failure of steel bars, which means the structure can deform gradually instead of collapsing instantly, providing precious time for people to escape. If such overstretched thin steel bars are used in construction, buildings may suffer sudden brittle collapse, leaving no chance for survival. Therefore, even though cold working can improve strength, all relevant construction specifications must be strictly followed, and the safety bottom line must never be crossed. Having finished explaining cold working at room temperature, we will finally talk about the art of fire and water, heat treatment. Simply put, Heat treatment is a process that heats steel to a specified temperature, maintains the temperature for a certain period, and then cools it down. It changes the internal microstructure of steel to obtain the required mechanical properties. As the name suggests, heat treatment definitely involves heating and temperature rising procedures. In ancient times, people found that high-strength and high-hardness steel was extremely difficult to process manually. However, once heated, steel softens significantly and can be easily forged and shaped. Moreover, the cooling method after processing directly determines the quality and performance of a forged sword. Ancient Chinese master swordsmiths had fully mastered this principle, which includes 4 core processes. 1. Normalizing, heating the steel followed by natural cooling in the air. This process increases hardness while slightly reducing plasticity. 2. Annealing, heating the steel and allowing it to cool slowly beside the furnace. This relieves the internal stress of the steel, improves its plasticity and toughness, yet reduces its strength. 3. Quenching. This is the classic sizzling scene often seen in movies and dramas, immersing red-hot steel into water rapidly. This boosts the strength to its peak instantly, yet makes the steel extremely brittle. It may break with a slight impact. Then, how to forge a peerless sharp sword that never breaks easily. The master craftsman's secret lies in the final step, tempering. After their apprentices finish work, the masters will secretly reheat and keep the quenched swords warm beside the furnace. This procedure enables the sword to retain high hardness while recovering the lost toughness. Therefore, if you travel back to ancient times and mastered the secret combination of quenching and tempering, you could also become a famous master craftsman. Everyone, whether adopting cold working similar to physical muscle training or heat treatment combining fire and water, we always stick to one core goal: balancing strength and toughness according to actual engineering requirements. Please remember, technology can modify material properties, but as professional engineers, we must control such power with strict specifications and professional ethics. That's all for today's class. See you next time.